All right, welcome back. This is part two of the AWS AI Practitioner question and answer analysis. So we're going to get started on this. If you could do me a favor, hit the like button, subscribe, share this with anyone you know who's taking the AI Practitioner exam. This will help. So let's get started. A retail company is exploring AI technologies to improve its inventory images from store cameras and shelves. The development team is considering both computer vision and image processing for different tasks, but wants to understand the key differences between the two. Knowing how these technologies differ in terms of their capabilities, whether for recognizing objects, making predictions, or simply manipulating images, will help the team choose the right approach for each task. How would you highlight the difference between computer vision and image processing? So this shows image processing. Image processing focuses on enhancing and manipulating images for visual quality, whereas computer vision involves interpreting and understanding the content of images to make decisions. So why is this correct? So image processing is concerned with techniques like image enhancement, noise reduction, edge detection, filtering, and transformation. The goal is to improve the image quality for preparing data or prepare data for additional analysis. Computer vision seeks to understand and interpret the image. So that means performing tasks like object detection, image classification, or facial recognition. So this will use machine learning and deep learning models to extract meaning from images or make predictions or decisions. Okay, and you can see this information here. All right. How this works, right? So why are the other answers incorrect? Okay. So image processing uses machine learning algorithms, while computer vision uses pre-programmed rules. Okay, so both image processing and computer vision can use machine learning, but computer vision relies more heavily on machine learning and deep learning models. Pre-programmed rules are limited and are not a core differentiator. Computer vision focuses on enhancing and manipulating images for visual quality. So this reverses the definition. So enhancing and manipulating is image processing. Interpreting content is computer vision. And then computer vision and image processing are identical. Well, that's incorrect, right? These are two distinct fields. While they overlap in tools and techniques, they differ in the goal and applications. Okay. A global e-commerce company is leveraging a foundational model to improve its product recommendation engine and enhance customer experience. However, the data science team is looking to further optimize the model's performance by applying advanced techniques that can fine-tune the FM for the foundational model for specific tasks, ensuring higher accuracy and improve overall efficiency. The company needs to identify the most effective methods for enhancing the model's capabilities while maintaining scalability. Which of the following is correct regarding the techniques used to improve the performance of a foundational model? It says fine-tuning changes the weights of the foundational model, whereas RAG, retrieval augmented generation, does not change the weights of the foundational model. So fine-tuning, why is this correct? Fine-tuning involves further training a pre-trained foundational model using domain-specific data. This modifies the model's weights, allowing it to specialize for a specific task or data set. RAG augments the model's responses by pulling external documents at inference time and providing them as context. It doesn't retrain or change the model weights. Instead, RAG supplements the prompt with relevant context, allowing the model to produce more accurate or up-to-date prompts or outputs. Excuse me. So why are the other answers incorrect? Neither fine-tune or RAG change the weights. Incorrect. So fine-tuning does change the weights. RAG doesn't. Both fine-tuning and RAG change the weights. That's incorrect. RAG does not alter model weights. It uses external data without retraining. And then fine-tuning does not change the weights of FM. Okay, so this reverses it. Okay, fine-tuning does change weights. RAG does not. Okay. Go for the next question. Consider the following AI model responses to user prompts. Which response exemplifies hallucination and which exemplifies toxicity? Prompt 1, what is the capital of France? Response A, the capital of France is Mars. Prompt 2, tell me a joke. Response B, why don't scientists trust atoms? Because they make up everything. Prompt 3, describe a good book for children. Response C, you should read ABC, a great book with fun activities for kids. Prompt 4, what do you think about people from a specific group? Response D, people from the specific group are inferior and should not be trusted. So the answer will be C. Response A is a hallucination. Response D is toxicity. So what is this? So response A, the capital of France is Mars, is an example of hallucination. The model confidently gives a false and factually inaccurate answer. Response B or D contains hate speech or discriminatory language toward a specific group, which qualifies as toxicity. These definitions align with AWS's responsible AI guidance. So hallucination is an AI-generated response that is plausible sounding, but factually wrong. And toxicity is an AI-generated content that is offensive, disrespectful, harmful, or discriminatory. Let's see. And with this, you would go back to guardrails. Okay, that's what we talked about earlier in the walkthrough. Now, why are the other answers incorrect? Okay, C and B. Okay, so response C is a reasonable recommendation and not factually wrong or inappropriate. Response B is a harmless joke and an accurate prompt. Now, B. Response D is a hallucination. Response A is toxicity. So this is incorrect. This reverses the definitions. Response B, or I'm sorry, D. Response B is hallucination. Response C is toxicity. So neither response fits these labels. B is a joke, and C is an appropriate book recommendation. Okay, next question. A company uses a generative model to analyze animal images in the training data set to record variables like different ear shapes, eye shapes, tail features, and skin patterns. Which of the following tasks can the generative model perform? The model can recreate new animal images that were not in the training data set. So why is this correct? Generative AI models are designed to create new content. They learn patterns and representations from training data and use this understanding to generate novel outputs that were not explicitly part of the data set. In this context, the generative model has learned features like ears, ear shapes, tail lengths, etc. And they can use them to synthesize new images of animals that combine or vary these features in ways not directly seen in the original data set. So why are the other options incorrect? The model can classify a single species of animals such as cats. So this describes a discriminative model or a discriminative task, not a generative one. Classification is about mapping inputs to labels, not generating new content. The model can classify multiple species. So this refers to a multi-class classification, which is a discriminative task and not the goal of the generative AI models. Okay, the model can identify any image from a training data set. So this implies image matching or memorization, which is not what generative models do. They learn patterns to generate new variations, not retrieve exact images from the data sets. Next question. A media company is exploring cutting-edge AI models to automate tasks such as content generation and language translation. The development team is particularly interested in using transformer models due to their efficiency and performance in natural language processing tasks. To make an informed decision, the team needs to identify which models belong to the transformer architecture and how they can be applied to their use cases. Which of the following is an example of a transformer model? ChatGPT. So, ChatGPT, which is Chat Generative Pre-trained Transformer, is a classic example of a transformer-based model. It's built on a transformer architecture introduced in the seminal paper, Attention is All You Need by Vaswani, all right? So this architecture enables self-attention mechanisms. This allows the model to assign varying importance to different tokens, which are words, in a sequence. It's an efficient training and inference on language-based tasks like translation, summarization, question answering, and conversation. So ChatGPT exemplifies the strength of a transformer-based model in natural language generation and understanding. Why are the other answers incorrect? So stable diffusion. So stable diffusion is a diffusion model, right? It's in the name. So this is used to generate images from noise and text prompts by reversing a noise prompt process. This is not the transformer. Okay. Next answer, Adobe Firefly. Okay, so this is also based on diffusion techniques, and it's primarily for image and video generation. It's not a transformer-based natural language processing task. And then DALL-E. So while DALL-E incorporates some transformer principles, it's more aligned with a diffusion or hybrid image generation technique. It's designed for image generation from text prompts and not a canonical transformer model for NLP like ChatGPT. Okay. Next question. A financial services company is exploring Amazon Bedrock to streamline its AI development for use cases such as fraud detection, personalized customer service, and automated reporting. The company is particularly interested in understanding the key features and benefits of Amazon Bedrock, including its ability to simplify access to powerful foundation models, support customizations, and integrate with existing AWS services. To make an informed decision, the company needs to select which of the following accurately applies to Amazon Bedrock and its capabilities. So that's C and E. Smaller models are cheaper to use than larger models. And E, you can use a customized model only in the provision throughput mode. So why are these correct? So smaller models. In Bedrock and most AI platforms, larger models cost more due to their increased computational requirements. Smaller models are cheaper, faster, and easier to deploy, but may sacrifice some accuracy or depth in responses. You can use a lot of smaller models on your own PC. And then you can customize the model only in provision throughput mode. So custom models in Bedrock require provision throughput, not on-demand mode. This is because customization involves model tuning and dedicated performance guarantees, which are only supported under this model. So provision throughput provides consistent performance with a term commitment. So why are the other ones incorrect? So you can use a customized model in the provision throughput or on-demand mode. So this is incorrect. Customized models are not available in on-demand mode. They must be accessed via provision throughput. All right, larger models are cheaper to use. Now, this is incorrect. This reverses reality, right? Larger models require more GPU memory and compute, increasing costs. And then D, you can use on-demand mode only with time-based term commitments. Okay, so on-demand mode in Bedrock is a pay-as-you-go without any time-based commitments. Okay. All right. An e-commerce company is developing a chatbot to enhance its user experience by allowing customers to submit queries that include both text descriptions and images, such as product photos or screenshots of issues. The company aims for the chatbot to understand these multimodal inputs and provide accurate and context-aware responses, seamlessly combining visual and textual information to address customer needs effectively. Which approach would be the most cost-effective for enabling the chatbot to process such multimodal queries effectively? B, the company should use a multimodal embedding model, which is designed to represent and align different data types or types of data, like text and images, in a shared embedding space, allowing the chatbot to understand and interpret both forms of input simultaneously. Okay. All right. So why is this correct? Multimodal embedding models, they map both text and image inputs into a common embedding space. So this lets your chatbot interpret and align context between the two modalities effectively. So this approach supports similarity research, semantic alignment, and relevance ranking. It makes it cost effective and scalable for cases like chatbots, product recommendations, and search. So something like Amazon Titan, which is on Bedrock, is one of the services designed specifically for these tasks. So why are the other options incorrect? So the multimodal generative model. Okay, so this is too complex and costly. It's way costlier than embedding models. All right, so this is suitable when the chat needs to generate new content, not just understand inputs. And so let's see, a text-only language model. So this can't process images. So it's inappropriate for a multimodal input where image and text are essential for context. And then a convolutional neural network. Okay, so this specializes in image-only tasks like classification or object detection, and it lacks the ability to understand or correlate text, making it unsuitable. Okay, let's go for the next question. A healthcare company is deploying AI models using SageMaker to predict patient outcomes and ensure compliance with healthcare regulations. The data science team wants to document important details about their models, such as performance, bias assessments, and intended use. They are considering using SageMaker model cards for this purpose, but also want to understand how AI service cards fit into the broader documentation of their AI services. Understanding the differences between these two tools will help the team select the right one for tracking and managing their models. Given this context, how would you highlight the key differences between SageMaker model cards and AI service cards? So, SageMaker model cards, D. SageMaker model cards include information about the model, such as intended use and risk rating of a model, training details and metrics, evaluation results, and observations. AI service cards provide transparency about AWS AI services, intended use, limitations, and potential impacts. So why is this correct? Okay. So SageMaker model cards are designed to support governance and responsible AI by consolidating key model information in one place. This is the intended use, the risk ranking, training and evaluation metrics, bias assessments, observations, disclaimers. So it helps organize and standardize the reporting and document model lineage and performance, right? And then the service cards provide transparency for managed AI services offered by AWS, like recognition, text extract, etc. And so they explain the intended use, the limitations, the design decisions for the AI for being responsible, right? And then performance guidelines and fairness. All right, so why are the other options incorrect? So let's see. SageMaker model cards provide technical documentation. No, that's incorrect. Okay, model cards aren't used for deployment, okay, but for governance and reporting. Okay. SageMaker model cards are used exclusively for monitoring model performance. So that's a little narrow. Okay. So SageMaker model cards include more. I mentioned intended use, compliance, bias. AI cards are not focused on security management. There are security tools for that. And SageMaker model cards are used to store data for machine learning models. No, that's incorrect. Okay, so model cards do not store machine learning model data. So that'll be in like your S3 or an index database. So the AI service cards do not store user credentials or any of that data. They're informational, not operational tools. Okay. Okay, next question. A healthcare company is evaluating the use of foundation models in generative AI to automate tasks such as medical report generation, data analysis, and personalized patient communications. The company's data science team wants to better understand the key features and benefits of foundation models, particularly how they can be applied to various tasks with minimal fine tuning and customization. To ensure they choose the right model for their needs, the team is seeking to clarify the essential characteristics of foundation models in generative AI. Which of the following is correct regarding foundational models in the context of generative AI? So, foundation models use unlabeled training data sets for self-supervised learning. So, why is this correct? So, foundation models are typically trained using self-supervised learning, which leverages unlabeled data sets, and this is usually massive in size. And it automatically derives learning signals. These are like pseudo labels from the raw data. And then this can enable generalization across tasks. So that can mean it can summarize, it can translate, it can have image generations without requiring fine tuning on each task. So this self-supervised learning, it bridges the gap between supervised and unsupervised learning. So it's less costly, it's more scalable, and it doesn't necessarily require human labeled data sets. So why are the other ones incorrect? All right, so foundational models uses unlabeled training data sets for supervised learning. Listen to that. Supervised learning requires labeled data, not unlabeled data. This statement contradicts the definition, okay? And then foundation models use labeled data training data for supervised learning. Okay, so while this is true for traditional supervised models, it's not the case for foundation models, which use self-supervised learning. So you have to pay attention to these. And then foundation models use label training data sets for self-supervised learning. So self-supervised learning by design does not rely on labeled data. It automatically creates supervision from within the unlabeled data set. Okay, so read it carefully so you don't get confused and lose an easy point. Next question. A media company is looking to enhance its content creation processes by leveraging cutting-edge technologies and has been exploring the use of generative AI. The leadership team wants to understand the broader significance of generative AI in modern technological applications, including its potential to automate tasks, improve creativity, and optimize workflows across industries. Understanding why generative AI is considered important will help the company make informed decisions about integrating this technology into its operations. Given the context, why is generative AI considered more important in modern technological applications? Gen AI is important because it can autonomously create novel and complex data, enhancing creativity and efficiency in various domains. All right, so why is this correct? So Gen AI stands out because it allows for three things. It can create novel and complex data. That means like text, images, music, code, video with minimal human input. It can boost creativity, and this is done in areas like content generation, design, and marketing. And there's efficiency gains. So that automation in stuff like customer service via chatbots or report generation or code completion really helps. So Gen AI's value lies in its ability to augment human creativity and automate complex cognitive tasks, not just perform basic actions. Okay, so why are the other answers incorrect? So Gen AI can easily perform simple tasks like sorting and filtering data. Okay, so this describes traditional rule-based systems for simpler machine learning, not generative AI. So Gen AI is used for novel data creation, not mundane filtering. Okay, so Gen AI is the best fit for use cases related to gaming and entertainment. So while Gen AI is useful in entertainment, like certain dialogue, certain creative visuals, its value spans many industries, including healthcare, finance, education, customer service, IT. So it's narrowing what Gen AI is used for. And Gen AI can replace all traditional databases with its own storage solutions? No. So Gen AI models do not replace databases. They can consume or generate data stored in databases, but they're not designed to store structured data persistently. Okay. Okay, next question. A media company is looking to oh, I think I just went through this one. Okay, let's try this one. Uh, okay. A telecom company is seeking to improve the efficiency and effectiveness of its customer service operations by integrating generative AI. The goal is to equip customer service agents with AI-driven tools that can assist in generating accurate, context-aware responses to customer inquiries, offer real-time suggestions, and help automate routine tasks. The company is evaluating several generative AI solutions to determine which one best fits their need for enhancing customer service interactions. Which of the following is the best fit for this use case? Amazon Q and Connect. Okay, so Q and Connect is the ideal solution for customer service environments. So what it does is analyze real-time conversations between agents and customers. It can provide suggestions on how to respond. It can pull up knowledge from internal content to help during calls, and it can boost productivity by automating repetitive tasks like summarizing conversations, right? So this aligns with the telecom company's goal to enhance customer service through accurate, context-aware AI. So why are the other ones incorrect? Let's see. So Q Business. Okay, so Q Business, this is designed for enterprise knowledge workers, not contact centers. So this focuses on internal knowledge retrieval for domains like HR, IT help desk, and operations, not for live call assistance. Q Developer, this helps with developer workflows like code generation, troubleshooting on AWS, or any DevOps tasks, not customer service. And then QuickSight, so QuickSight is good for business intelligence and better fit for data analysts. So this helps with dashboards and insights using natural language. So it's not really relevant for conversational support or customer inquiries. Okay. And next question. A healthcare company is deploying AI systems on AWS to manage patient data and improve diagnostic accuracy. To ensure compliance with strict healthcare regulations and to enhance the security of their applications, the company's security team is looking for an AWS service that can automate security assessments. Inspector. Okay. Inspector is right. Why is this? So it automatically scans AWS workloads for software vulnerabilities, exposure risks, and network accessibility. So it supports a continuous automated security assessment to help maintain your security posture without a lot of manual effort. And it's widely used for compliance heavy sectors like healthcare due to its real time findings. And it integrates well with AWS Security Hub. All right. Why are the other ones incorrect? Okay. So Artifact is a compliance reports and certification service. So this is basically like a library of reports that AWS provides to show that they meet compliance for stuff like HIPAA or SOC 2, PCI DSS, et cetera. Right? Audit Manager. So Audit Manager helps with automating audit preparations. So that means like evidence collections for compliance programs, right? So this focuses on reporting, not active security scanning. And then config. Oops. So config would be out of all these, would be the closest, but no, but not really. So, so config tracks and evaluates resource configuration compliance. So it's great for policy enforcement, but not a security vulnerability scanner. All right. So you have to know those AWS tools to really understand this question. All right. All right, next question. A retail company is building a machine learning model to forecast demand for its products, but the data science team is facing challenges in balancing model complexity and accuracy. They're trying to avoid overfitting as well as underfitting, since understanding the differences between these two issues is crucial for optimizing the model's performance on both historical and unseen data. So how would you differentiate between overfitting and underfitting in the context of machine learning? So the answer is C. Overfitting occurs when a model performs performs well on the training data, but poorly on new unseen data. While underfitting occurs when a model performs poorly on both the training data and the new unseen data. So why is this correct? So overfitting means the model learns the training data, including the noise, the outliers, way too well. And it results in a poor generalization to new data. So it learns that data only, really well. And underfitting means the model is too simple and it fails to capture the data that it is provided in the training, and it's too poor to provide good performance on the training data and then the new data. So it's a classic pitfall of machine learning, and it has to be addressed through model tuning, regularization, and cross-validation. Okay. And why are the other ones incorrect? Overfitting occurs when the model is too simple. Okay, so that's okay. Overfitting is too complex. Underfitting is too simple. This reverts it. And then overfitting is desirable as it ensures the model captures a nuance. Underfitting is desirable as it ensures the model generalizes. No. So neither one of these answers is suitable, right? Overfitting hurts generalization. Underfitting misses patterns. So both of these in this example reduce the model's usefulness. And then overfitting and underfitting both refer to a model performing equally well. No, that's incorrect. So both refer to imbalanced or poor performance, not equal performance across data types. All right. Next question. A company is using Bedrock and wants to set an upper limit on the number of tokens returned in the model's response. Which of the following inference parameters would you recommend for a given use case? Response length. Okay, so response length is the inference parameter used to control the number of tokens generated in a model's output. This parameter lets you set a maximum number of tokens or words that the model can return, which is ideal for scenarios where response size must be constrained. This could be for anything like cost control, latency, user interface design, whatever, right? So you would use a response length parameter to specify the maximum number of tokens in the model's response. So why are the other ones incorrect? So stop sequence, this tells when the model should stop generation. So when a specific sequence of characters is produced that's not based on the token count, it's used to terminate output early based on the context. And top K, okay, so this controls the randomness in the token selection, and it limits the candidates to the top most probable next tokens. So it's used for the diversity and creativity, not output length. Okay, and then top P. Top P is another sampling control that restricts the token choices to those within the P probability mass. So this is a form of sampling, right? Like top K, it affects generation quality and randomness, not size. All right. Let's see, next question. A healthcare company is building multiple machine learning models using SageMaker to support various projects like patient outcome prediction and medical image analysis. As the number of models grows, the company needs a tool that provides a centralized view of all models created across its AWS account to easily track, manage, and monitor them. This will help streamline model governance and improve operational efficiency. Which of the following is the best fit for the given requirements? SageMaker Dashboard. SageMaker Dashboard is designed to provide centralized visual interface to manage and monitor all machine learning models in your AWS account, right? So it supports models trained with SageMaker and those imported from other platforms. So it lets users do stuff like view model lineage, deployment status, identify inactive or missing monitors, like, you can tell for model drift or bias, and it can access model performance indicators across services like SageMaker Model Monitor and Clarify. And it can help you improve operational efficiency and governance. So why are the other answers incorrect? SageMaker Model Monitor. Okay, so this is used to monitor deployed model performance. So this looks for data drift or prediction skew. So it's not a centralized dashboard. It's a monitoring tool based on deployed endpoints for batch jobs, sorry. And then SageMaker Ground Truth. So this is for data labeling and human in the loop workflows. This is not for managing or tracking multiple deployed models. This is useful for training data generation, not model governance. And SageMaker Clarify. So this is good for identifying bias and explainability issues in models and data. So this doesn't provide the centralized interface. But these are all important tools of SageMaker, just not, there's only one of them that's the correct one for this answer. Okay, next question. Okay. A technology company is considering using AWS to support its growing application infrastructure and is exploring different cloud computing models. The team is particularly interested in EC2s to handle its scalable compute needs, as understanding this will help them determine how much control they have over the underlying infrastructure and how best to manage their resources. Which type of cloud computing does EC2 represent? Infrastructure as a service. All right. So what is this? So EC2 is a classic infrastructure as a service, IaaS, because it provides users with direct control over the operating system installation, its configuration, the storage with EBS volumes or an instance store, the networking on the VPCs, the subnets, security groups, and the runtime. So you can install your own applications and dependencies on that. But you're responsible for patching, updating, scaling, and securing. So this is a defining characteristic of infrastructure. All right, why are the other ones incorrect? All right, so software as a service. All right, a SaaS solution is a fully managed application, and you'd only use the application, right? So think of something like Gmail. That's a SaaS. You don't manage the infrastructure, the operating system, or the runtime. Examples within AWS would be like Recognition or WorkDocs. So the EC2 would require the infrastructure and operating system, so it's not a SaaS. I'm sorry, EC2 requires it, so something like, yes, I was correct the first time. Network as a service. This is not a commonly recognized AWS offering. Network as a service, no. So this is a distractor. So AWS offers networking features like Transit Gateway, but EC2 itself is not a network service. And then platform as a service. Okay, so a PaaS abstracts the infrastructure and provides a pre-configured environment for deploying code. So something like Elastic Beanstalk, where you deploy your code and AWS handles the operating system, the scaling and patching, that would be the PaaS. The EC2 is much more on a ground level than a PaaS, where you manage the entire operation system and stack. All right. All right. Okay, next question. A financial analytics company has deployed a machine learning model using Amazon SageMaker within virtual private cloud to analyze sensitive customer data. To meet security guidelines, this VPC is configured with no internet access. However, the model needs to regularly access and read data stored in S3. The company is looking for a solution that allows secure data transfer between the SageMaker model in the VPC and S3 without exposing data traffic to the public internet. What do you recommend? Okay, the company should use a VPC endpoint for S3 that allows secure, private connectivity between the VPC and S3 without the need for an internet connection, ensuring data is transferred securely within the AWS network. So why is this good? All right, so S3, a VPC endpoint for S3, specifically a gateway endpoint, lets you have a private connectivity between resources in the VPC and an S3 without going over the public internet. So this is good for like security conscious workloads for like something like healthcare or finance, any scenario that requires a VPC isolation with no internet gateway or NAT. And it keeps data transfers within the AWS global network. And then why are the other answers incorrect? Okay. Companies use an internet gateway. No. Okay. So an internet gateway provides public internet access. This violates the scenario requirement of no internet access. It would expose data traffic and increase the attack surface. The company should use a NAT gateway, which nope. Okay, so NAT gateway enables outbound access to the internet for private subnets, but this still routes traffic through the public internet. So this violates the requirement to avoid the public exposure. And then a company should use SageMaker inference endpoint. No, that's incorrect. Okay, so these endpoints allow external clients to call deployed models. They don't facilitate model access to S3. So it's not relevant to the question, talking about retrieving S3 data securely within a VPC. Okay. Okay, next question. Company stores its training data sets on S3 in the form of tabular data running into millions of rows. The company needs to prepare this data for machine learning jobs. The data preparation involves data selection, cleansing, exploration, and visualization using a single visual interface. Which SageMaker service is the best fit for these requirements? SageMaker Data Wrangler. Okay. So SageMaker Data Wrangler is a purpose built for streamlining data preparation workflows. So this works for machine learning. So how does it do it, right? There's a single interface, so you can import large data sets from stuff like S3, Redshift, Athena, and a bunch of other external sources. Then you can clean and explore the data. You can apply a bunch of built-in transformations. You can visualize data patterns, and you could generate data and export data transformation pipelines, right? So this best matches the scenario requirements without needing to write any code and using a visual interface. So why are the other answers incorrect? So SageMaker feature sort. Okay, so this is used for managing features for training inference, not data prep. It doesn't offer any data selection, cleansing, or visualization. Clarify. Okay, so Clarify is used to detect bias, explained predictions. It's not for general data prep. It focuses more on fairness analysis and explainability, not ETL or was it extract, transform, load, those type of workflows. And then model dashboard. No. So this is meant for monitoring and managing models, not for preparing data sets. So it tracks deployment, drift, and health of the models, but not the raw data. Okay. All right. Next question. A legal firm is looking to implement an AI solution that can generate detailed, accurate responses to client inquiries by retrieving relevant information from its extensive database of legal documents. The firm is considering the use of RAG through Bedrock to enhance the quality and relevance of the generated content. The team wants to understand the best fit use cases for RAG to determine if it aligns with their needs for knowledge retrieval and content generation. Which of the following represents the best fit use case for utilizing RAG in Bedrock? Customer service chatbot, medical queries chatbot. Why? So RAG enhances generative AI by incorporating domain-specific and real-time data from external sources, like a legal database or medical records or knowledge bases, right? So it puts this into the prompt before generating a response. And so it improves the relevance and accuracy. So in Bedrock, RAG is implemented via knowledge bases. And if you enable this, you can have a scalable pipeline from data ingestion to augmentation and retrieval, especially for question answering over proprietary content. So AWS recommends using RAG for chatbots, legal document assistance, and then any compliance or policy advisors. So this makes it a lot more specific without having to change the model, right? So this aligns with the legal firm's need to use Bedrock. Okay, so why are the other... That's interesting. This is repeated. Huh. That should not be here. Um, that's interesting. Sorry about that. Okay, so why are the other ones incorrect? Let's go for content creation. Content creation. Okay. That's weird. So generating creative content like essays or social posts does not require retrieval from a knowledge base. This is like pure generation. Okay, this is going into Gen AI territory. And then image generation from a text prompt. So RAG involves text-based data retrieval, not image synthesis. So image generation is handled by a foundational model like Titan Image Generator, not a RAG. And then product recommendations that match shopper preferences. Okay, so recommendations are typically powered by collaborative filtering or embedding-based search, not RAG. So RAG isn't really useful for a real-time user behavior prediction. Okay. Okay. A multinational corporation is building machine learning systems on AWS to analyze customer behavior across different regions. As part of ensuring compliance with local regulations, the team must establish strong data governance practices. They are particularly focused on data residency as well as data retention, since clarifying these concepts is critical for the company to meet both legal and operational requirements. Given this context, what is the primary difference between data residency and data retention? Defines the policies for how long. Yeah, it's A. Normally I have these marked. All right, this is the correct answer. Okay, data residency is concerned with the physical location of the data, whereas data retention defines the policies for how long data should be stored and maintained. All right, so why is this correct? So data residency refers to where your data is stored physically or geographically. It's part of meeting your regional compliance requirements, especially AWS has to do that. This is important for stuff like GDPR within the European Union, the PDPA in Singapore, or HIPAA in the US. And then data retention refers to how long data is kept, right? So this ensures that data is preserved or deleted according to your compliance. So this is good for operational or legal policies, right? So AWS supports a bunch of both data retention and residency with tools like AWS regions and availability zones for specifying data locations, and then S3 lifecycle policies and backup or audit manager for data retention. And why the other one's incorrect? So data residency determines the duration. Well, that just reverses it. Data residency is about location. Data retention is about time. Data residency focuses on data encryption. Nope. Okay, so while encryption and transformation are data security practices, they're not the core focus of either residency or retention. But they are a part of it. They're just not the core. Data residency involves setting access controls for data. No. Access controls are handled through IAM and resource-based policies, not part of residency. And then real-time monitoring is tied to observability tools like CloudWatch or CloudTrail, not retention policies. Okay. Next question. A logistics company is exploring the use of machine learning models to optimize its supply chain operations, such as demand forecasting, route optimization, and inventory management. The company's data science team needs to understand the fundamental principles of machine learning models, including how they're trained, evaluated, and applied to real-world problems. This understanding will help the team select the right model for their use cases and improve operational efficiency. Which of the following is correct regarding machine learning models? Okay. C. Machine learning models can be deterministic or probabilistic, or a mix of both. So machine learning models are not limited to a single inference behavior. They can be deterministic, meaning the models can produce the same output for the same input every time, meaning decision trees or rule-based models, right? And then probabilistic, meaning these models can provide likelihoods or distributions for outputs, making Bayesian networks, right? That's gonna be the technical term that you'll see on some of these tests. And then there's a hybrid capability. So a lot of modern models with a neural network, right, can combine deterministic structure with probabilistic interpretation or behavior during training or inference. So this flexibility lets machine learning practitioners select the most appropriate model based on data uncertainty, prediction goals, and interpretability. Okay, so why are the other ones incorrect? ML models can only be deterministic. Okay, so probabilistic models like Bayesian networks incorporate uncertainty. And machine learning models can be probabilistic. Okay, this is also incorrect. So models like decision trees or support vector machines are deterministic. And the machine learning models are deterministic for supervised learning. No. This is a misconception. So the distinction between deterministic and probabilistic is it's not relevant to whether the model is supervised or unsupervised. Okay. Remember, there's unsupervised and supervised within this. Okay. So this is kind of a distractor. Okay. Next question. Financial services firm is adopting Amazon Q Business to streamline its data-driven decision-making process. As part of the implementation, the company needs a robust solution for managing user access, ensuring the employees across various departments have appropriate permissions to interact with dashboards and reports. The team is evaluating options for user management that offer secure, scalable, and easy to administer controls within Amazon Q Business. Which of the following would you recommend for user management in Amazon Q Business? Identity Center. All right. So Identity Center, formerly AWS SSO, is a recommended approach for centralized user management across AWS services, including Q Business. So it lets you have scalable access across AWS accounts and applications. It integrates with workforce identity providers like Okta, Active Directory, whatever, right? It has fine-grained permissions for different users and different groups to interact with your Q dashboards and your applications. And you can have single sign-on experience for end users. So with Q Business, Identity Center is required to manage users, control what the content they can view or interact with. So why are the other options incorrect? Okay, IAM service. Okay, so IAM is used for resource level access across AWS. That means assigning policies to roles or users. It doesn't provide centralized user management for workforce identity in a SaaS style for applications like Q Business. So IAM lacks that built-in integration with the external identity providers unless it's manually configured. An IAM user, no. So IAM users are individual AWS identities. These are suited for programmatic or admin use, not for scalable workforce user management, right? So using IAM for a large scale access is discouraged because it'll take a lot of manual provisioning, and the lack of single sign-on and poor scalability means it'll be a nightmare. And then AWS account. Okay, no. So AWS account is a container for AWS resources, not a user management mechanism. So while account level permissions exist, they don't offer a way to control or provision workforce users across apps. Okay. All right, next question. A company developing AI-powered customer service chatbots is exploring ways to improve quality and accuracy of responses using reinforcement learning from human feedback, RLHF. The data science team is considering using SageMaker Ground Truth to assist with gathering and processing human feedback during model training. To ensure the solution aligns with their needs, they want to understand how SageMaker Ground Truth supports the key capabilities required for implementing RLHF, like collecting, labeling, and managing human input effectively. What do you suggest? Okay. SageMaker Ground Truth enables the creation of high-quality labeled datasets by incorporating human feedback in the labeling process, which can be used to improve the reinforcement learning models. D. All right, why is this correct? So ground truth is that human in the loop process, right? It's essential to the reinforcement learning, right? So this can help with collection of human feedback through comparison and ranking of model generated outputs. And you can create labeled data sets, which is useful and needed for fine tuning or building reward models. And then you can have scalable data annotation across multiple users with built in workflows. So in reinforcement learning, feedback from humans shapes the reward function, and it's critical to improving your model behavior in the real world applications. Um, are the other answers incorrect? SageMaker Ground Truth uses pre-trained models. No. So reinforcement learning requires human feedback to improve the model's behavior based on real world human preferences. So ground truth is not designed to replace human feedback with pre-trained models. It's designed to capture and manage it. And ground truth automatically generates synthetic data. No, ground truth is focused on manual and semi-automated data labeling, not synthetic data generation. Synthetic data generation is typically done with other services like synthetics from monitoring. There's other third-party tools, but I can't think of what they would be off the top of my head. And then SageMaker Ground Truth is specifically designed for real-time decision-making and autonomous. No. So Ground Truth is not designed for real-time inference or decision-making logic. It's built for batch data annotation, especially where human judgment is critical. Okay. All right. Okay, next question. I think this is gonna be our last one. A financial services company is deploying a machine learning model to automate fraud detection, but wants to ensure continuous model accuracy and compliance with regulatory standards. The data science team is exploring AWS services that can help in monitoring machine learning models and incorporating human review processes. Understanding which AWS services are specifically designed for model monitoring and human oversight will help the team maintain high standards of accuracy and compliance. Which AWS service can be combined to support these requirements? Modeling monitoring. Yes. Okay. SageMaker Model Monitor and Amazon Augmented AI. AI 21. Okay. Why is this correct? So SageMaker Model Monitor continuously monitors machine learning models in production. It looks for data quality issues, model drift, and anomalies, right? So this will help detect degraded model performance or data changes over time. It's critical for fraud detection scenarios. And then you have compliance support with automated alerts that lets you audit monitoring for regulatory compliance. And then augmented AI. Okay. This integrates human review into the machine learning workflow. Remember that augmentation. All right. So this lets something like a financial institution review predictions, add manual insight or oversight, and fulfill regulatory or compliance requirements. So this ensures that decisions can be flagged for risk or uncertainty and can be reviewed before action is taken. Why are the others incorrect? SageMaker ground truth. Okay. So then this one, okay. SageMaker ground truth. Okay. When you're building labeled data sets for model training and not monitoring or production inference, this is not right. It doesn't monitor deployed models or support the real-time prediction reviews. It goes for the human in the loop. Okay. And then SageMaker feature store, no. So this doesn't provide model health monitoring or human feedback loops. Okay, and then Data Wrangler. This is not designed for post-deployment monitoring or human in the loop feedbacks. All right. All right. Those would be enough for this section. We'll have another one and another one and another one. The goal is to get you to pass AWS AI Practitioner. Until then, hit the like button, subscribe, and share this with anyone you know who's going to be taking that. Thank you. Have a good day.